Yes, morning. Welcome today for this project review. And our project is a counterfeit review detection project. The author, Mumza David. This project will implement a counterfeit review detection system to prevent consumption of non-standard products by online users. This is because usually non-technical consumers find it hard to check the details of the product properly at the delivery, and this becomes dangerous at consumption of fake products, which affects health and involves unfair competition with financial costs. So, a fake review is a review written or generated without actual experience of the product or service offered. Next, we shall see the data set used. I'm giving an example of Amazon e-commerce data set. And under that, I'll be using a model called GPT-2 model that can generate a data set for classification task of fake review detection to achieve more perfect goal due to its accuracy and boost of tested algorithm, which are already tested, and at least they can help do perfect work. So factors why I chose the data set is because accuracy. During classification, for example, you say that human beings usually judge 65%, and then machines are 86% at highest. So another factor is quality, being realistic and secure for instances that are applied. Next, we have performance. This data set is usually a general purpose generated data set. It covers a lot of the ideas in this sector. So then it's a viability. It has a viability of data set, which will include images and text, and it's trustworthy. So those are the factors that I've considered. Quality is among them. So the important features in the data set will include the textual, let's say metadata, data about data. This includes words, prices, and description. The next, which I have images, the visual, what you can see. The logo images using deep learning. Size and ratings. This will include shape and existence, usually, since they are usually sorted by the user. We have the category files. The data set of Amazon is usually categorizes things. So files are individually categorized according to products used. Next, among the terms that we shall be using in the presentations and that I will be applying, we shall use Bayes' theorem, which is a mathematical formula for determining condition probability. That is to say, under here we are seeing P given B equals to P given B times A over B. So that is P representing the probability. So in the next continuation, we are seeing that the Bayesian theorem, known as Bayes' rule or Bayes' reasoning, helps in determining the probability of an event with uncertainty knowledge and provides a way to update probabilities given new. This is usually applied in probability theory and employed in financial sector with the calculating and updating risk evaluation. So we can also apply that in our machine learning. Bayesian network. With this type of, we have the Bayesian networks as a type of probabilistic graphical model that can be used to build models from data and expert opinion. Tasks that usually involve prediction, diagnostics, automated insights, reasoning, time, and series prediction. Even when you are doing decision making in uncertainty, that will help you in the network. So, in the continuation, Bayesian uses probability distributions once the structure has been defined. We remember in the network we have nodes, variable, and links. And also we can use the laws of probability such as addition, multiplication, and complement. Naive Bayes. Naive Bayes is a system or a simple algorithm that utilizes Bayes together with a strong assumption that attributes are conditionally independent given the class. So, naive Bayes often delivers competitive classification accuracy. The competitive or computation efficiency will involve linear training time feature that leads to naive Bayes being widely practiced and applied. So when we continue with the naive Bayes, once estimates are got, classifications and other decision support applications are given. So if you estimate, then the classification becomes easier. For example, probability of A given B of each class, A given an object B. So using naive Bayes is a probabilistic classifier, which means predicts one or on the basis of the probability of the object. What is the difference between Bayes' theorem and naive Bayes? Bayesian theorem assumes no conditional independence, and the other one assumes conditional independence, as we see that A and B are conditionally independent given C. So then when we come to the algorithm, Bayesian theorem, the algorithm is slow, but the other one is fast. This is because the relationship between all input features are independent. Then another thing is simple models for Bayesian theorem. Usually we deal with simple models. And then for naive Bayes, outperform complex models. We take an example of the difference. If you want to calculate a single condition probability given all features, you use Bayesian theorem. Or if simply you want to calculate the conditional probability for each feature, then multiply them together, naive Bayes works for you. We are seeing down there some examples with some conditions given and sets. So then we go to the difference between naive Bayes and Bayesian networks. Now here we're dealing with networks and naive Bayes. For naive Bayes assumes that all the features are conditional, independent of each other. And then Bayesian networks, all dependence in Bayesian network has to be modeled. You have to model them by yourself. So assumption works well for most cases, even if they are not really independent. Then in Bayesian networks, they are usually learned by the machine itself. If it is sufficient of then the current dependencies, or if then it has the sufficient knowledge of the current dependencies. Technically, you can assign class labels to the samples from the variable set of label. Then in a Bayesian network, graphical model can present a set of variables and their conditional dependencies. So naive Bayes is usually restricted. For example, the class nodes should have no parent and other cases. Then features are selected based on some score functions and minimal description. For example, length as enough in training data. Simple due to assumptions made for naive Bayes. Then Bayesian network is more complicated because it involves nodes, links, anything that is of network. Usually that's the way it is. Then lastly, the references are these, and these ones you can check them via internet. You just have to input in the URL and then you can read about the references. For example, artificial intelligence, a modern approach by Stuart J. Russell and Peter Novick. So that could be a very important reference. Once again, thank you for watching, and don't forget to subscribe on my YouTube channel. Thanks. Have a good time. Thank you.